Hi, Miss Marion here. This is the second day for Inequalities. Again, you will need your note page. That is on the Canvas page for Inequalities Day 2. You will also need the worksheet. Again, that's the Canvas assignment, is the worksheet. Same thing, okay? You will need both of those printed out, so you might want to go ahead and pause that after we talk about I can statements so we can solve one-step equations, one-step inequalities with one variable in a real world situation. We're going to be talking about word problems. So you really need your note page and your worksheet printed out. So go back and do that and then come back to me. All right. So we need to do some vocabulary first before we can go ahead and go into our word problems. So the first one is greater than, right? It's also known as is more than. Is larger than, and also above. You should be writing all of this down on your note page. The next one is also known is greater than or equal to. Is greater than or equal to, right? Greater than or equal to. It's also known as the minimum, at least, is not less than, and last one, not smaller than. Okay, so kind of everything bigger, right? Next one is less than, right? We know that. Could also be is smaller than, below, and fewer than. Okay. Next one, maximum, meaning you can only go up to that number. At most, not more than, and is not greater than. And we also know it is less than or equal to. Let's try that one more time. Let's erase some of that. Or, let's actually erase it. Okay, so all of these, make sure you get all this written down because you're going to need to refer back to it when we're doing our sentences. Okay. All right. 5 more than a number is less than 17. So let's go ahead. I like to annotate this mathematically. I know annotation, English stuff. Yeah, I'm sorry. So we're going to say 5 more than tells us to switch a number. So X is less than. Is less than is actually on our page, and that's the less than, and then 17. Okay, so the intro is we're going to define what we're talking about. So we're going to say let X equal a number. Body is our equation. So we're going to say, because we have this kind of switch stuff going on, we're going to say X plus 5 less than, and then 17. And then the conclusion is we're actually going to solve it and then kind of write a sentence about it. Okay? So this is our equation. We have X plus 5 less than 17. We're going to go ahead and we see a plus 5, so we are going to subtract off 5. Grab a calculator, do 17 minus 5. 17 minus 5 is 12. We still have our X, so let's bring down then our less than. So this is, so we have X is less than 12. Okay, what does this really mean? It means all the numbers less than 12 will be our number, like our missing number. Okay, so all the numbers less than 12, we can put it into this equation. It will always still make it true. All right, example number 2. 5 is greater than 6 less than twice a number. Okay, a lot of stuff going on there. So we have is greater than, and then 6 less than. So 6 less is subtract, this than is the switch, okay? Because if you look at your notes before, is greater than is the greater than kind of stuff. And then twice times a number, and then we have 5, and then we also have 6, right? So this is kind of like a mathematical notation. Intro, let's define some stuff. So let x equal a number, okay? Body is our equation, 5 greater than, and then we have to switch stuff. We have to do 2x subtracts 6, and that's because of this and than right here, right? And then we're going to go ahead and we're going to solve it, right? So I want to be able to get x by himself. I have to look at the minus 6 or the negative 6. I have to add 6 to both sides. 5 plus 6 is 11, greater than, and then 2x. And then 2 is multiplying the x. So again, we're solving it just like solving equations, right? So 2 multiplied by x, we are going to divide by 2 on both sides. 11 divided by 2 is 5.5, greater, and then x itself. For us to be able to solve it, to kind of talk about the final answer, remember we always want the variable on the left-hand side. Is the variable on the left-hand side? It is not. So I'm going to do x, 55. Above, the arrow is pointing towards the x, so on the bottom, I have to make it pointing towards the x itself. So now it's x less than 5.5. So all the numbers, the conclusion, all the numbers less than 5.5 is our missing number, or is the answer, so we can put into this equation to still make it true. Okay, awesome. All right, example number 3. The sum of 3 times a number and 12 is fewer than 20. Okay, so again, let's underline some stuff. Is fewer than, that's our inequality. And if we go back up to our where we have it all written down, that is just the less than. Okay, sum 3 times a number and 12, okay, is fewer than 20. So intro, let x equal a number. Okay, I'll put it together. So 3 times sum of 12 less than, and then 20. This is our equation that we're going to go ahead and do. So again, we're going to go ahead and we're going to solve it. So we want to get 3x by itself first of all. So I have to go ahead and move that 12. So we are going to subtract the 12 off. We want to make a 0. I see a positive. I want to make a 0, put a negative with it, or I see addition. We are going to go ahead and subtract. So we're going to take our calculators. We're going to say 20 subtract 12. What do we get? We get 8, and then less than, and then we have 3, and then x. 3 and x, they are multiplying, so I'm going to remind myself that is multiplying. What's opposite multiplication? That is division. 8 divided by 3 is 2.6 repeated. And then 3 divided by 3 is a 1. It leaves the x by himself. Is my variable on the left-hand side? Yes, it is. Do I need to change anything or move anything? No, we're going to keep it that way. So what's our conclusion on this? So all the numbers less than 2.6 repeated is our missing number. Or also all the numbers less than 2.6, if we put it into the equation, we'll always keep this equation to be true. All right, so here we're actually into the actual word problem itself. It says Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 in his account by the end of the summer. He withdraws $25 each week for food, clothing, and movie tickets. Writing inequality represents Keith's situation. And then how many weeks can Keith withdraw money from his account? So I'm just going to define my variable right off the bat because it says how many weeks can he withdraw. So I'm going to say let W equal the number of weeks Keith can withdraw money. Okay. Now let's kind of go through, let's annotate. So he starts with $500 in his account. He wants to have at least $200. And then he does $25 per week. So he has $500. He's taking off $25 per week. Do we know how many weeks? No. So I'm going to put in 20 in there. And he wants to have at least. So that's going to be greater than or equal to the $200. So he wants to have $200 or more. It's okay to have the or more, just not the less. Okay. So let's go ahead and solve this. So we have 500. We want to get W. Eventually, we want to get W by himself. Who else is around that W? Well, that's the 25. But who else is also there? That 500. So I'm going to go ahead. This is a positive 500. I'm going to subtract off that 500 from both sides of the equation. We still have the minus 25 left over, 25W greater than or equal to 200 minus 500 is negative 300. Negative 25 and W, they are multiplying, so we are going to divide. So negative 25. Okay. So negative 25 divided by negative 25 is positive W, or positive 1, or leaves W by itself. Negative 300 divided by negative 25 is positive 12. Now remember, we divided by a negative number on both sides of the equation. So we are going to actually flip this sign to make it less than or equal to 12. Okay, remember, we divided by, if you multiply or divide by a negative number on both sides of the equation, you have to flip your sign. So we had to go ahead and do that. Okay, so our final answer right now is W is less than or equal to 12. What does that mean? That means that Keith can withdraw $25 each week. Well, let's put that in there too. So let's do that. Up to 12 weeks. And then this is our answer. All right, example number 5. Connor went to the carnival with $22.50. He bought a hot dog and a drink for $3.75. He wanted to spend the rest of the money on ride tickets, which cost $1.25 each. What is the maximum number of ride tickets that he can buy? So let's go ahead. Let's define our variable. What are we looking for? Well, he's looking for the number of tickets. So we're going to say let X equal the number of tickets Connor can buy. Okay. Let's kind of go through and annotate. He starts with the $22.50. He buys the $3.75, and it's $1.25 per ticket. Okay. So he has the $22.50. All of that has to be less than or equal to the $22.50, so he can't go over it. And what did he do? So he has the $3.75 is what he bought, plus the $1.25 per ticket. Okay, cannot be over the $22.50. There is another way of setting this up. This is just how my brain understands it. Is like the $3.75 plus the $1.25 times how many tickets you have cannot go over the $22.50. Okay. There are other ways to set this up. This is just how I am doing it, okay? So again, I want to get X by himself. That's my ultimate goal. So what's outside of that X? Well, we have that $3.75 kind of sitting there. And that's a positive $3.75. So I'm going to subtract it from both sides. Okay? So if I subtract $3.75, that makes it 0. The $1.25 per ticket. Still have the less than or equal to. And then 22.50 minus 375 is $18.75. And then 125 is being multiplied by the x. So then multiply, okay? So then we need to divide. So 125 divided is a 1. It leaves x by himself. Less than or equal to 18.75 divided by 1.25 equals 15. So what does this actually mean? It means that Connor can buy up to 15 tickets. All right, example number 6. It says Sean earns $6.70 per hour working after school. He needs at least $150 for a stereo system. Write an equation that describes how many hours he must work to reach his goal. So let's go ahead and let's define our variable, okay? So I'm going to say let H, because he's working hours. So let H equal the number of hours Sean must work. And we can say like for his stereo, okay, but how much he has to work, okay? So now let's go ahead and let's write the rest of the equation. So we have the $6.70 per hour, and he wants $155 for the stereo system. So it's $6.70 multiplied by his hours that he works needs to be greater than or equal to the 155. Okay, so we know that, and then that's our equation. So we know that 670 is multiplied by the h, so we're going to divide by 670 on both sides. Okay, and then 670 divided by 670, that is a 6 by the way, is going to leave h by itself. Greater than or equal to 155 divided by 670 is 23.1343, kind of keep on going kind of stuff. So do a lot of people, normally when you work, you want to work out of hours, okay, and full hours. Yes, you can do halfers, okay, but we're going to do it as just full hours itself. So he actually needs 24 hours, okay? 24 or more hours is really what it actually is saying, but he at least has to have 24 hours. So it is Sean must work at least 24 hours, and we can say to get his stereo system if we want to, okay? So today was all about word problems, and you might want to have to go ahead and like stop this and rewind it anytime you can if you don't understand something. But again, this is what we're doing as far as today. We're doing the word problems with the inequalities and then solving them. Okay, have a great day. Thanks. Bye.